Hi, everybody. Welcome to week 11. Today's lecture will focus on two pivotal topics in NLP: question answering systems and machine learning for chatbots. We'll begin by understanding how QA systems work and their real world applications before diving into the machine learning techniques essential for developing advanced chatbots. Let's start by outlining our objectives for this session. Without further ado, let's jump right into it. By the end of this session, you should have a thorough understanding of the mechanisms behind QA systems, the different types of machine learning applied to chatbots, and how LLMs like GPT-3 enhance chatbot capabilities. I'll also provide resources to help you build on what we discussed today. Now let's move on to an introduction to QA systems. QA systems are specialized NLP models that answer user queries using natural language. Unlike basic search engines, QA systems aim to provide direct, context-aware responses. For example, in an interactive customer portal, if a user asks, "How can I reset my password?" a QA system would respond with clear instructions instead of simply linking to a support page. With this foundational understanding, we'll explore how these systems operate in more detail. Next, we'll look at the workflow of QA systems. To understand how QA systems work, it's helpful to break down their workflow. First, the system parses the user's question to identify key components. Next, it retrieves relevant information using algorithms like vector space models. Finally, the system extracts or generates an answer using models such as BERT to ensure contextual accuracy. For instance, an educational app might answer, "What is the theory of evolution?" by synthesizing information from biology resources. Moving on, let's explore a real-world application of these systems. In practical use, legal research tools are a great example of QA systems. These tools help legal professionals quickly access relevant case law and summaries by inputting specific questions like, "What are the latest rulings on environmental regulations?" The system retrieves case briefs and highlights key rulings, saving hours of manual searching. This example shows how retrieval-based technology can provide specialized, direct responses. Now, let's transition to the next section, where we'll discuss machine learning techniques for chatbots. Next, as we discuss machine learning for chatbots, it's important to understand the various approaches. These include supervised learning, which uses labeled data for training, unsupervised learning for finding patterns in unlabeled data, reinforcement learning for training through interaction and feedback, and transfer learning, which adapts pre-trained models like GPT-3. Each method has distinct strengths and applications, which we'll explore in detail. Let's begin with supervised learning. Supervised learning is one of the most reliable methods for training chatbots, especially for well-defined tasks. For instance, a support chatbot for an e-commerce site might be trained to answer, "What are your store hours?" with, "We are open from 9 a.m. to 9 p.m. This technique provides high accuracy when labeled data is available, making it popular for customer service bots. However, it requires significant data preparation. Next, we'll explore how unsupervised learning contributes to chatbot development. Unsupervised learning helps chatbots discover hidden patterns without labeled data. For example, a retail chatbot might learn that questions about returns and refunds often overlap. This insight can guide the creation of more targeted responses and content organization. Although unsupervised learning is powerful for data exploration, its outputs may require further processing to be actionable. Now, let's move on to reinforcement learning and its role in training adaptive chatbots. Reinforcement learning, RL, trains chatbots through feedback loops, allowing them to adapt over time. Picture a language learning bot that receives positive feedback when users say, "This explanation was helpful." The model uses this reinforcement to improve its responses. While RL is beneficial for dynamic environments, it does require extensive interaction data and ongoing adjustments. Now, let's see how transfer learning and LLMs fit into chatbot development. Transfer learning leverages pre-trained models like GPT-3 to build chatbots quickly. For instance, a financial assistant bot could be fine-tuned with BERT, trained on investment FAQs, making it capable of answering questions like, how do I start investing? With clear, informative responses. Transfer learning saves time and uses pre-existing language understanding, though fine-tuning large models can be resource intensive. Now, let's explore real-world applications and some hands-on resources for you to try. Chatbots are used in diverse fields, from virtual financial advisors that offer investment tips to educational tools that help students with subjects like algebra. To practice creating chatbots, use resources like the Hugging Face Model Hub, where you can experiment with pre-trained models. Google Colab is perfect for running code in the cloud, and Kaggle provides datasets to train and test your models. With these tools, you can start applying what you've learned. Now, let's shift to discussing ethical considerations in chatbot development. Developing chatbots and QA systems requires addressing ethical considerations. One major issue is bias in training data. If a dataset includes biased language or lacks diversity, the chatbot's responses can perpetuate stereotypes. Ensuring the dataset is balanced helps minimize this risk. Privacy concerns are also vital. Chatbots often handle sensitive data, so robust data protection and compliance with laws like GDPR are necessary. Transparency is key. Users should know when they're interacting with AI and be aware of its limitations. Now let's look at how we evaluate chatbots. Measuring the effectiveness of a chatbot involves various metrics. For generative models, we use BLUUU and RAOJ scores to assess how closely responses match human written text. Beyond technical metrics, tracking user experience through engagement and satisfaction scores is important. Are users finding the chatbot helpful? Are their questions being answered clearly? Contextual accuracy ensures that the responses are relevant and factually correct. Advanced applications often use real-time monitoring tools to spot issues and improve responses on the fly. Now, let's address some of the common challenges in this field. Machine learning for chatbots comes with its challenges. Data requirements are significant. High quality, large-scale datasets are essential for effective training. The computational demands can also be a hurdle, especially when training or fine-tuning models like GPT-3. Handling out-of-domain queries where a user asks something the chatbot wasn't trained for remains a challenge. Lastly, there's the issue of overfitting, where a model performs well during training but struggles with new data. Regular testing and using diverse data can help improve a model's generalizability. Now, let's conclude with future trends in QA and chatbot development. Looking ahead, multimodal integration is set to transform chatbots, combining text, audio, and visuals for richer interactions. For instance, a travel assistant bot might provide verbal responses along with images of recommended destinations. Adaptive learning is also on the horizon, enabling chatbots to learn from interactions in real time and adapt their responses. Personalization will continue to grow, allowing bots to tailor responses based on user history. Finally, advances in ethical AI will push for more transparency and fairness, ensuring that these technologies benefit all users. Let's wrap up with key takeaways from today's lecture. Today, we covered the structure and function of QA systems and the various machine learning techniques for chatbots, including supervised, unsupervised, reinforcement learning, and transfer learning. We discussed the influence of LLMs like GPT-3 significantly shapes how we create responsive chatbots. We also addressed ethical considerations, evaluation metrics, challenges, and future trends in the field. Remember, hands-on practice is key to reinforcing these concepts, so make use of platforms like Hugging Face, Google Colab, and Kaggle for further exploration. Thank you for your attention, and I look forward to diving deeper into these technologies in our upcoming sessions.